Guys, I'm going to teach you all about the equations of perpendicular lines. By the end of this lesson, you'll be able to write the equations of perpendicular lines in slope-intercept form. The first thing you need to know is the definition of perpendicular. Perpendicular lines are lines that intersect to form a 90-degree angle. Based on this definition, highlight or circle the perpendicular lines in the figures below. You can see that the perpendicular lines all have that little square. That little square represents 90 degrees, and that means there's a right angle. Keeping this in mind, we have four lines, R, S, T, and U, intersecting to form a rectangle on the coordinate plane. Rectangles are made up of four right angles. So there's some perpendicular lines. There's also some parallel lines. So my first question is, which pair of lines should have the same slope? R and S should have the same slope because those lines are parallel. T and U should have the same slope because those lines are parallel. Now let's actually find the slope of each line. For R and S, you only need to find the slope of one of those lines since they are parallel, and you can see that the slope is -3/2. On T and U, those lines have a slope of 2/3, and both are positive. Now looking at the figure, let's list two pairs of perpendicular lines. I could have said R and T and S and U, and now we can compare those slopes of one of the pairs of perpendicular lines. I'm looking at R and T. If you look at these two slopes, is there any conjecture or guess that you can make about the slopes of any two perpendicular lines? Hopefully you noticed a pattern that is going to happen for any set of perpendicular lines. The slopes of perpendicular lines are opposite reciprocals. That means to find the slope, flip the fraction, that's the reciprocal, and change the sign, that's the opposite. Here's an example with number 1. First, we'll identify the slope. The slope is 4/5. If we want a line that's perpendicular to this equation, we would do the opposite. The opposite of positive 4/5 is -4/5. And then we want to flip it to 5/4. That's the opposite reciprocal. The slope of that line that's perpendicular would be -5/4. Let's look at number 2. If it's already negative, the opposite of a negative is a positive. And then the reciprocal would be 2/1, or just 2 in this case. Keeping this new fact about the slopes of perpendicular lines, see if you can find the slope of a line perpendicular to the given equation in 3 and 4 all by yourself. All right, since 5 was the slope, the opposite reciprocal would be -1/5. -10 is the number that's next to the x, so that's our slope that's given. The opposite of a negative is positive, and then the reciprocal of 10 is 1/10. Next three problems, we're going to write the slope and the equation in slope-intercept form for lines that are perpendicular to the given line. Starting with number 5, we're going to write the equation of a line that's perpendicular to this and contains the point 0, 3. See if you can do that and press play when you're ready to check. Number 1, you would start out by getting the opposite reciprocal of that slope since it's perpendicular, and then we want our y-intercept. In this case, it's given. 0, 3 is the y-intercept. So the equation of the line would be y equals -4/3 x plus 3. Number 6, we want to write the equation of a line that's perpendicular, so we'll start by doing the opposite reciprocal. In this case, 3 is the new slope, and then we want to plug in our point. So we would start out with writing y equals 3x plus b, and then let's plug in that point. -2 is the x value, and then 7 is the y. So we can plug that in and then solve for b. The perpendicular line would have a slope of 3 and a y-intercept of 13. So the equation of this perpendicular line is y equals 3x plus 13. Using these examples, see if you can do number 7 all by yourself and then press play when you're ready to check. The first thing you should do is identify the slope of the perpendicular line. The opposite reciprocal of 6 is -1/6. When we write our equation in slope-intercept form, we would plug in 12 in for the x, -5 in for the y, and then solve for the b. b equals -3, and b is our y-intercept. So the equation of the line would be y equals -1/6 x minus 3, and that line would be perpendicular to this one. On the graph, I sketched a dotted line that's perpendicular to the x-axis. My line crosses the x-axis at x equals 3. So x equals 3 is the equation of the line. Any line that's perpendicular to the x-axis will be vertical and have an undefined slope, just like my line. On the graph, I drew a solid line that's perpendicular to the y-axis. My line and any line that's perpendicular to the y-axis would have a horizontal line drawn and have a slope of 0. I was writing the equation for a line that was perpendicular to the x-axis and passed through this point. It would look like this. Because that line would have an undefined slope and pass through the point -8, x equals -8 would represent the equation of that line. For a line perpendicular to the y-axis, it would pass through the y-intercept of 11, and it would be at 11 the whole time with a 0 slope. So y equals 11 would represent that line. Go ahead and try number 9 all by yourself, and then press play when you're ready to check. All right, since the slope of the given line is -1 or -1/1, we know that the slope of the line perpendicular to that would be the opposite, which is 1, and the reciprocal, which is still 1. So we could then plug in our point and then solve for b. In this case, b is 9, which is our y-intercept, so it would cross up here. Given our equation, y equals 1x plus 9. For number 10, they may look perpendicular, but you would really need to use the slope to determine if lines f and g are truly perpendicular. When you have that, justify your answer. As you can see, line F has a slope of 2 over 1, while line G has a slope of negative 1 over 1. Those numbers are not opposite reciprocals, so the lines are not perpendicular. All right, that's it. Thanks for watching. If you have any questions, please let me know. Bye.